All right, 5 routers. We're going to start from the right side, and this is how the configuration goes. Interface loopback has got 2 IP addresses. One is IPv4, another one is IPv6. And the physical interface. The name of the interface is F00. F00. There is no IPv4 on this, only v6. Sorry. Done. Later we'll do the routing protocol. Do show history. You see, I'm going to copy this to a notepad and use it for the rest of the routers. On router 4 F01, this will be 4. And F00, this will be 34, 4. And this is going to be 4, 4, 4, 4, 4. And this will be 4, 4, 4. If you have any question, stop there only. If you find me doing some mistake, stop there only. Don't allow me to paste it, then correct it. It will take time. Huh? Is any correction needed here? Is there any correction needed here? This is on router 4. Let's go to router 3. On router 3, F01 will have 3 here. F00 will have 24. That's all. This is on router 3. Now router 2's configuration. F01 of router 2 will have 2 here. And this is going to have 12, 2. Router 2. Now router 1. That's all. So I've finished configuring IPv4 and v6 address wherever it's needed. IPv4 it's only needed on loopback, and IPv6 on both physical and loopback. It is done. As a verification, what I'll do is I'll just ping the adjacent device. Ping R1 2000 colon 12 colon 1. Oh, sorry, I should have put 1. No problem. Meanwhile, I'll go to R4, ping 2000 colon 34 colon 3. I'm able to ping. I'll also ping 45 colon 5. I'm able to ping. So adjacent device I'm able to ping. On router 2 also I'll put the right one, pinging router 1 2000 colon 24 colon 3. I'm able to ping. So what do we understand? IP addresses are properly configured. Let's start configuring RIP-ng on route 1. Listen carefully. Any routing protocol, you must type this command IPv6 unicast routing. See what happens if I don't give. If I don't give, what happens? You see, interface loopback 0, IPv6 RIP. I'm going to give a name. Can be any name. I'm giving delay. Just a name. Delay enable. This is the syntax. IPv6 RIP and a name. This name is a process ID. And then enable keyword. You see, it says you have not enabled IPv6 unicast routing. You have not joined that FF02 colon 2 multicast. That's what it shows. So first put this command and then go to loopback 0 again and enable RIP. Done. This time no error message. Likewise, enter. I have also enabled RIP on F00. See how easy it is to enable IPv6 RIP. You don't need to go to the global mode. But if you are redistributing, then you have to go to the IPv6 router RIP. I'll do that on router 3. On these routers, there is no need to go to the router mode. You need to go to only the interface. This name, this can be Kuppan, Choppan, Kandan, any name. And it need not to be same on every router. It can be different. All right. So I'm going to go to router 1 to prove that. I can also use the range command, interface range loopback 0, F00 -1. IPv6 RIP. There I gave delay. Here I am giving jitter. Enable. See? Again, same problem. I forgot to give this IPv6 unicast routing command. Now I go back to the range of interface and enable RIP. Done. You see, on router 1, I did not use the process ID as jitter. I used process ID as delay. Here I'm using jitter. Now, by now I should see some routes from router 1. Let us check. Show IPv6 route RIP. Look at this. I learned this from router 1. And you see it is learned via the link local address of router 1. I have learned it via the link local address of router 1. Now we are moving on to router 3. Interface loopback 0. Before that, what is the command? IPv6 unicast routing. Interface range loopback 0, F00. Only on these two interface, I'm going to run RIP. So loopback is inside RIP only, not in EIGRP. Your wish. You can put it in EIGRP or RIP whenever you decide. IPv6 RIP. There I gave delay, and the next router I gave jitter, and then now on this router I'm going to give packet loss. Pack loss. Enable. That's it. Now I should see the route from both router 1 and router 2 reflecting in the routing table of router 3. Show IPv6 route RIP. Ba-bam. This is the loopback of router 2. This is the loopback of router 1. And this is the network between router 1 and 2. And if I wish to ping this, I will be able to. I can ping this with my source 3333::3. Hey, 3, buddy. Okay, pinging. Not even a single drop. It is because of the neighbor discovery that happens using link local address ICMP version 6. RIP is enabled. Any question on RIP? See, if you know IPv4 RIP, everything is same. The timer, everything is same. Only the configuration approach is different. How often updates are sent? Same, 30 seconds. You see, debug IPv6 RIP. You can see every 30 seconds, RIP will be sending the updates to the neighbor. Look at this. And it is using the link local address to send. And you also see the metric has been advertised, hop count. Right? You also see the RIPs multicast address. FF02::9 is RIPs multicast address. This is the link local address of the sender. Sending router. Router 2 is sending. Okay. Okay. All right. So I stop this and I can see here received. From this multicast address. Okay. So it has received some RIP updates called 3333::3/128 coming from router 3 with a metric of 1. That's right. For router 2, this is 1 hop away. And also, this is 2000:24, which is also advertised by router 3 with a metric of 1. This is router 3's link local address on F00. If you want, you can verify. Go to router 3, show IPv6 interface brief. On F00, you will find, look at this, 48, okay? 48. All right. Any question on RIP? Okay. Now we are moving on to IPv6 EIGRP. Afterwards, we will redistribute EIGRP into RIP and RIP into EIGRP. Let us now do EIGRP. See, EIGRP is somewhat new approach. Listen, for EIGRP, you have to do it on global mode as well as interface mode. So first you go to global mode, IPv6 router EIGRP. Autonomous system number. I would like to give autonomous system number as 111. EIGRP autonomous system 111. And then what I have to do here is no shutdown. Stay. That's all. This is what new. Usually we used to say no shutdown on the interface. But in IPv6 you have to do it on the router EIGRP. Now you go to interface. Interface F01. IPv6 EIGRP 111. That's all. You have enabled EIGRP and you have also enabled EIGRP process by saying no shutdown on F01. Let's verify. Show IPv6 EIGRP interfaces. You can see EIGRP autonomous system 111 and it is running on F01. Now going to router 4. Listen carefully if you have missed something on router 3. Listen. On router 4, IPv6 router EIGRP 111. Okay, IPv6 unicast routing command first, then get into EIGRP and say no shutdown, and then come out. And I'm going to say interface range loopback 0, comma F0/0-1 and say IPv6 EIGRP 111. That's all. You see, you can see already the neighbor is established with router 3. This is router 3's F01 link local address. You want to see F3, sorry, router 3, F01, see 446. Okay, now let's go to router 5. IPv6 unicast routing, IPv6 router RIP, sorry, router EIGRP 111, no shut. And then go under the interface, loopback interface range loopback 0, comma F00, IPv6 router EIGR, IPv6 EIGRP 111. That's it. That's all. Neighbor will come. Finish. Now I should see two neighbor in R4. So I do what? Show IPv6 EIGRP neighbor. Look at this. I got two neighbor. This 46 I know it is from router 3. 48 is from router 5. You want to check router 5? Show IPv6 interface brief. You should see 48. 48. So router 4 can see two neighbors. Now let's try pinging from R5 to R3's loopback. Show IP route EIG, show IPv6 route EIGRP. You can see the I don't have loopback of router 3 because we did not advertise loopback on IPv6 EIGRP. We advertised this 3333 colon colon 3 only on RIP. We can also do it on both. So let me go to router 3 and advertise also under EIGR. Interface loopback 0. Loopback is going to run both RIP as well as EIGR, IPv6, EIGRP101. That's it. Now, as a result, I'll be able to learn the routes on router 5. You see here. Now, let us try pinging from R5 to R3's loopback, sourcing from. I'm able to ping. So EIGRP is good, RIP is good. Now we need to ping from 5 to 1, for which we need to know how to do redistribution in IPv6 between RIP and EIGRP. I'll go to router 3, IPv6 router RIP. Oh, RIP in router 3, what name I gave? In R1, I think I gave delay. R2, I gave jitter, packet loss. Oh, the spelling do show IPv6 protocol. Here I will know. Okay, this is what the name we gave, packet loss. IPv6 router RIP process ID. Now redistribute EIGRP 111 metric hop count. What does that mean? Take all the routes given by EIGRP 111 autonomous system, and for EIGRP, use this metric as the hop count. Just, it need not to be accurate. Some number you need to give less than 15. I'm giving 3 for all the EIGRP learned routes. As a result, if you go down to router 1 now, show IPv6 route RIP. I am seeing even 55555, which means the redistribution is working very nice. You see, I said 3, right? I said 3. So when it comes to router 2, it becomes 4. When it comes to router 1, it becomes 5. That's why you see hop count 5. Yeah, you see hop count 5. All right, now will I be able to see the route of router 1 on router 5? No. Why I'm not able to see R1, R2 networks, or router 1, router 2 networks on router 5? Because we have not redistributed from RIP into EIGRP. So let us go to EIGRP now. See, earlier we went inside RIP and gave EIGRP. Now I have to go inside EIGRP and say redistribute RIP, RIP word name. What is the word we used? Packet loss, metric, K values. You need to give 5 K values. See, what is the bandwidth that you want me to consider for RIP routes? I'm saying 1000. What is the delay? Not much delay, less delay. Reliability, oh, highly reliable. What is the load? Hey, very less load, Empty 1500 only. That's all. You can also say include connected. Boom. Now, as a result, go to router 5 and check. You will be able to see all the routes. The routes that are coming from EIGRP, coming from RIP are called as external routes. So administrative distance is 170, same like IPv4. So if you know IPv4 well, IPv6 is easy. Now let us try pinging from R5 to R1. Ping from R5. 2 or 1. We are able to ping. Okay. So you have learned two protocols with redistribution.